gentlemen, cats, dogs, aliens, adults. I don't know who else could be watching this. That'd be actually pretty sick if a dog was watching this. But what's up, pup? I'd so pet you if I could see you right now. But in this episode, we're going to discuss dehydration, synthesis, and hydrolysis. These are big words, but they can be somewhat confusing concepts at first, but keep working with them. Trust me, they're very important, A, and B, they will make a ton of sense once you'll have that aha moment, and hopefully you'll have that after this mini episode. But if you don't, just keep working with it. I guarantee it will come. So let's start with dehydration synthesis. This is, in simple terms, in layman's terms, it's removing water to bond. So examples are always easy. So let's think of a monosaccharide plus a monosaccharide. You're forming a disaccharide here. So what happens is the monosaccharide, for the monosaccharide to bind to the monosaccharide, a water molecule needs to be removed so these two can combine. So how it would look is C6H12O6 monosaccharide plus C6H12O6 another monosaccharide. The arrow for the reaction there, we're going to form a disaccharide plus H2O. So we're going to have that disaccharide because the monosaccharide formed the disaccharide. But since dehydration synthesis is what allows these any really bond to form, whether it's a carbohydrate, whether it's a lipid as we'll see, whether it's a protein, whether it's nucleic acid, dehydration synthesis is extremely important, as well as hydrolysis, but we're going to focus on dehydration synthesis right now. So monosaccharide, water removed, it yields the disaccharide, so the big molecule, plus an H2O. So that H2O is removed from the monosaccharide to allow the disaccharide to form. But it doesn't just disappear into the ether, it is still on that side of the reaction. So the result of the C6H12O6, it would yield, let's think of it. So without removing the water molecule, it would be C6 plus 6 equals 12, C12, H24, 12 plus 12, O12. But since we're removing H2O, we're removing two hydrogens and one oxygen. So instead of C12, H24O12, we would have C12, remove two hydrogens, H22, remove one oxygen, O11. So the C6H12O6 plus C6H12O6 would yield C12H22O11 plus the H2O. So that H2O is removed from that combination of the monosaccharide, which allows the disaccharide to form. So dehydration synthesis essentially is removing water to bond molecules. So you take smaller molecules, remove water or many waters, and in this example would be one water. We'll see later on it could be many waters, but remove water, allow it to form, which allows that larger molecule to form. Now hydrolysis on the opposite side is pretty much the opposite, but let's discuss an analogy for dehydration synthesis. It'll tie into the hydrolysis as well. So dehydration synthesis, let's say this. So for two people to hang out in the same exact house, that must remove any animosity. So animosity would be the H2O here. So for two people to hang out, to bond together, need to remove that animosity. Now for hydrolysis, we'll dive right into the analogy and explain what that means afterwards. So for a couple to stop seeing each other, animosity needs to be added, which breaks the individuals apart. So the water needs to be added to break apart. So it's pretty much in any of these reactions, they're reversible reactions. So dehydration synthesis forms a larger molecule, hydrolysis breaks down that larger molecule. So dehydration synthesis removes water to bond, hydrolysis adds water to break down and absorb here. So the monosaccharide to monosaccharide with the disaccharide and water, that would be the dehydration synthesis, but it's actually a reversible reaction, so it can go this way. So the water is added to the disaccharide, which yields monosaccharide plus monosaccharide there. So hydrolysis is adding water to break down and absorb. And an example of this, we'll move away from the disaccharide. Let's just say a polysaccharide. So that's 3 monosaccharides bonded together. So monosaccharide, monosaccharide, monosaccharide. We're calling all of it a polysaccharide. And in this case, there'd be 2 water molecules. So monosaccharide, monosaccharide, monosaccharide. There's the water between these 2, and then there's the water between these 2 there. So we have a polysaccharide with 3 monosaccharides plus 2 H2O. Guess what? It'll yield a monosaccharide, and a monosaccharide, because that's hydrolysis. We're adding water to break down and absorb. So we could do the same reverse of this reaction, and it would be dehydration synthesis. So monosaccharide plus monosaccharide plus monosaccharide plus, or actually it would yield, excuse me, so monosaccharide, monosaccharide, monosaccharide. Write all these down too. It's much easier to see a drawing of a lot of this stuff. But the monosaccharide, monosaccharide, monosaccharide would yield 2 H2O and a polysaccharide there. So dehydration synthesis, remove water to bond, and hydrolysis is pretty much the opposite. You add water to break down and absorb here. So going back to the carbohydrate example, we'll do a real example, and then we'll touch back on the analogy here. So glycogenesis, reminder of what that is. Think of it for a second, then I'll give you the answer. So yep, hopefully you're thinking a bunch of glucose into glycogen. That's actually dehydration synthesis. So you don't see it whenever you just say glucose to glycogen, but glucose, many glucose, you remove water, it helps form that glycogen. But glycogenolysis, guess what? It's the reverse. So you take that glycogen, you sprinkle some water back in, it breaks down the glycogen into many glucose. That's glycogenolysis. So that's a real life example to think about. But in analogies case, so dehydration synthesis would be for 2 people to hang out in the same exact house. You must remove any animosity, any hate, any disdain, any anger. You must remove that for 2 people to bond together. But guess what? If you want for a couple to stop seeing each other, if you add that animosity back in, guess what? They're going to break apart, and that bond's going to be broken there. So that if you remove animosity, remove water, you're going to form bond. If you add animosity, you add water, you're going to break down into singular compounds and into smaller components, essentially there. So dehydration synthesis, remove water to bond, remove animosity to bond. Hydrolysis, add water, add animosity to break down and absorb. So they're the inverse of each other, essentially. Dehydration removes water to bond, hydrolysis breaks down to absorb, and we're going to see these with carbohydrates, we're going to see these with proteins, we're going to see these with lipids, and we're going to see these with nucleic acids as well. But yeah, it's all the same concept. So if you understand it now, it's going to make the future much easier for you and for us and for forever, essentially. So we'll see you back here soon.